Hello, welcome to Assembly Call. Today we are going to solve the 208 LeetCode problem. It's implement trie or prefix tree. So basically, if you read the problem statement, it's saying that we need to create some data structure called trie. In that data structure, we will going to implement three kind of method. One is for inserting any word, and one is the searching for word, whatever we inserted earlier. Another one is starts with. Right? In the starts with, we are basically we will check that is there any word is exist with the given search start with string, right? So basically we need to implement this setting. So okay, let's deep dive to this example and let's try to make better understanding what they want to say or what we want to develop. So basically I took the same example. So basically trie is a kind of data structure also for storing word and searching word, right? So its an advantage is that we used to take only order of n time for insertion and order of n time for searching also, right? So how trie works? Let's try to build our trie tree, right? So this is if you take the name, it's saying the prefix tree, right? So it's kind of tree only, right? So let's try to insert the first character, first word, right? So suppose we want to insert apple in our trie data structure. So for that I am going to I need to create one. I need to design algorithm for insertion, right? So let's insert that. So what trie data structure says, each node. So basically you need to consider these two nodes also, that we can have only A to Z small lowercase letters only, and we will not get any non-empty strings, right? So since we are just considering lowercase for this problem, we can just think we can consider should A to Z means total 26 character only, right? So not more than that. So every time it will be fixed, right? So basically what trie data structure says is, so suppose I want to insert my apple, right? So I will take I will consider my first character and I will check that is that character is exist on in our trie or not. So how we can check that? So basically for each and every character we are going to maintain a separate node, right, in a tree. So in a tree we have node, right? So for each and every node we are going to maintain a separate character for that, right? So basically I will start from, suppose it's my root node, right? So this is my root node, right? So this is my root node. I want to start inserting my I'm just inserting my apple word, right? So I will check for the apple, right? So this one. So I will see, okay, so there is nothing for apple, right? So there is no node exist. Initially it is blank, right? So I am going to insert apple here, right? So let me insert A. Then I will check, is there anything P after A? So does A have any child for P? I think again there is no child, right? So I am going to insert P here, right? So let's insert P here. Now after that I need to check the same thing for, is there anything for did P have any child for P? So I already told you, right? Since we are just considering small lowercase character, so each and every node can have at max 26 nodes, right? 26 child nodes. So again I will see there is no child node for P, right? So again I will create one other new node and I will insert P there. After that we need to check it for L, right? So how we can check for L? So basically again P does not have any child for L, right? So I am going to insert L there. After that what I need to check? I need to check for E. Again for E we don't have anything, right? So we are going to insert E here. Okay. So let me quickly connect this, and then after that I will try to insert another word. So let me connect this first. So this is how it will look like, guys, for our trie. Okay, so now what I will do, so okay, so there should be another connection. Okay, so now what I will do, I will try to insert this second character, this one, right, app. So again I will start with A, right? So let's start with A, and I will say, okay, A is already there, right? So we don't need to create a separate node for A, right? In the index 0, A is already there, so we are not going to insert anything, right? We are going to reuse that character node. Okay, so now what I will do, I need to check for P, right? So again I will see that, okay, P is also there, so then we don't need to create anything, right? Then again I will come here, right? And here I can see, okay, I have again P, so P is already exist. So we don't for inserting the app word, we don't need to create any extra nodes, since app is a subword of apple, right? But somehow whenever we will search, we need to identify that this is the end, right? So for each and every node, character node, we are going to each and every node will have two properties, right? One is the one is with the child, so it should have at max 26 child, and it should have one flag associated with it, right? So using that we can understand, okay, this is the end of my word. So we don't, so if whenever we are going to search anything, then using that flag we can identify, okay, this is the end of a word. That can be a subword, but that is also a word, and so using that flag we can identify that word is exist or not, right, in our try. So for each and every node we are going to maintain one flag, right, and I will set that flag as true. That means this is our end of a one particular app word, right? So similarly we will do it for apple also, right? So again I am going to set my flag here true, right, so that I can identify later this is a word we already inserted, right, in our try. Okay, so now let's try to insert another word. So let's take an example. So suppose we want to insert one word like appy, something like that, appy, right? So how we can do that? So again I will check, a is already there, p is already there, p is already there, but whenever I will come here, then I will see p has only one child, only, that is I, right? So there is no child called y, right? So basically again I need to create another node, and I am going to insert y there, right? So after inserting appy, or it will look like this, and obviously I need to set my flag true here, right? So this is how the try data structure look like. So suppose if you have any word from bat or something like bad, so there should be a separate array for the same, right, bad. So let's take the example for bad also, right, quickly. So if I want to insert bad, so what I will check, okay, so there is nothing for b, right? I am going to create one b for b, then again I need to create for a, and then again I need to create for d, right, since there is no child exists for b, right? So again let me quickly connect that. So it should be like this, and okay, so it will look like this, right? So our try will look like this. Again I will need to make this flag true, right? So it should be flag should be equals to true, right? So that I can identify this is the end of a word, right? So this is how the insertion happened, right? So let's try to understand the logic for similarly for search also. So how we can search? So basically we are going to use the same logic, right? So at first I will check for each and every word. Suppose I am checking for apple, right? So I will check for a and I will found it. Okay, then I will check for p, again I will found it. Then again I will check for p, again I will found it. But we need to stop at in one condition, right? So here we will stop once we find all the 5 characters. So apple has 5, its length is 5, right? So whenever I will find all the 5 characters in our try, then we are going to return true from there only, right? But there is another scenario also, right? So suppose I want to search for app, right? Here I found a, then p, and again I can see, okay, I found all my 3 characters, but it can happen that we did not inserted this app, right? So in that case so suppose it's a substring of a actual bigger string, like for app is a substring of apple, right? So if I found so suppose we are searching for app and I found that, then I need to check that is that a really end of a word, whatever we inserted. So in that case we are going to check this flag, right? If it is true, then we will going to return true, right? That means that word is exist. If it is false, then we are going to return false. Then means app is exist in the try, but that is not the actual string we inserted. That's probably a substring, right? So that is the case. So if it is false, that means app is not inserted, right? So whenever we insert the app, then only we make it true, right? So suppose we did not insert this, right, and we just forget this, right? So if we did not insert it, so it should be false, right? Then in that case I am searching for app. I will find app, but I will see that, okay, it will be false, right? If we have not inserted it, it will be false. Then I am going to return false. Actually the word is exist, but we have not inserted it. Probably it was a substring of apple. Okay, so this is how we can search it, right? And another one we starts with, so that's also kind of similar to search. Basically we need to start with app, right? So I will see, okay, a is exit, p is exit, p, but in that case we don't need to check the flag, right? Since we are just checking the starts with, not the actual word. So apple is also start with app, right? So in that case I am going to return app. So we don't need to check flag for in that scenario. So let's proceed and let's try to code it out in Java. So one by one. So at first we will do for insertion, then search, then start with, right? Then I will also give you code walkthrough. So what I will do? So at first I will take another separate Java project class, and probably I will name it as try node only, and it should have two properties, right? One is the boolean, that boolean flag, that is its end of not. So probably is end. Let me name it like this, is is a leap node. Leap means end, right? So it should be okay, and there should be another. So each and every node can have maximum 26 child, right? So it should be an array, right? Array of trie nodes. Okay, so let me declare that also, and let me name it as child only. Okay, child. Now let me create one constructor, default constructor, public trie node, and let me initialize this value also. So how we can initialize it? So initially this dot isLeaf will become false, and this dot child will be a new trie node array of 26, since we are considering lowercase letter a to z only. Okay, I think that's pretty much for the poser. Now let's try to insert it, right? So before inserting, we need to declare one variable here. It should be type of trie node, and let me name it as root only. And in the constructor, we are going to initialize it. So it should be this dot root. It should be this dot root equals to new trie node. Okay, we are just calling this constructor, right? This constructor. Okay. Now let's move forward. Let's try to insert it, right? So for inserting, we will get one word as the input, right? So what I need to do, check first. So what I will do, I will take one temporary node here. So probably equal to t or temp and something like this. And temp, its name should be temp. And inside that, initially it will point to root only, right? Root index. Now what I need to check. So let's go back to our actual diagram, right? So I need to insert apple. So at first I need to check that a is exist or not, right? So let's check that. So how we can check that? Consider one thing, that we are using integer array, right? So since we are considering 0 to 26, so somehow we need to convert this character to integer to get the actual index, right? So how we can do that? It's pretty simple. So probably we can take another integer temporary variable. In that we are going to store the actual index, right? So it should be word dot char. So it's a pretty inbuilt method, char@, using which I can pick up the current character of that word. So I will pick it up for initially what it should be. So basically, okay. So basically, we need to check. We need to suppose I am inserting apple, right? So since we are inserting apple, I need to run a for loop from a to e, right? So since we need to insert all the character, right? So let's define one for loop here. So it should be int I equals to 0, and I should be less than word dot length. Next, what it will be, and after that I need to increment I counter, right? After that, what I need to do, I need to check this logic, right? So I need to pick it up, the index. So it should be char@I, and so since it's a character and character contains the ASCII value, I am going to do the -a, right? So basically a character starts from the 65, right? So basically, since our index is 0 to 26, so suppose it's apple, for a it's a, right? This will return a minus a. So 65 minus 65 is 0, right? So basically a will be saved in the 0th index, right? Similarly, it will be for b and c and d, right? So basically, to get the index, we just need to do minus a character, right? So that will give me the actual index, right, in the trie array. Okay, now let's move further. So I got my index, right? So now I got my index. I know that a, right? So now I need to check, is that index a null or not? If it is a null, initially it will be null, right? Then in that case, I need to initialize one new index, right? So let's do that. So how we can do that? So I am going to just check that what was my temp, right? Temp dot child, and what was our index j equals to null. Nulls means that there is no node exists for a, right? So for that case, what I am going to do, I need to create one. I need to initialize one new trie node, right? So let's do that. So temp child j should be a new trie node. Okay. Now what I need to do, once we are done, so if I found it, whenever I am done with the creation of new node, I am going to insert my value there, right? So I am going to initialize that there, right? So I need to go further, right? So what I will do, so it should my new temp will become, so until up to this, what we have done here. So I found this child, I found that there is no node for a. I initialized one new node and I inserted there. Now I need to move further, right? I need to check it for p. So I need to increment my counter, right? So let's do that. So if my temp will be temp dot child, and it should be j, right? So I think okay, so it will run for each and every character. Now once we are done with that, we are just, so we inserted apple here, right? So I came till here, right? Now I need to set this flag, right? So let's set this flag after the for loop. So what it will be, it should be temp dot, what was the attribute name? It was isLeap, right? So isLeap, that means it's end, isLeap equals to true. I will make it true. So that's a end of a word. So apple, then E is the last word or last character, right? So that I make it true, right? Now let's do the implementation for search. So basically for search also we are going to use the same logic. We are going to take one try temporary node. Let me name it as temp again. I will start from root. Now what I need to check, I need to check that okay, so what I will do, so since we need to check it again and again, right? So we are going to use recursion, right? So we are going to declare a separate function, right, for search, and I'm going to call that function inside this search function, right? So let us create a private function. So we are not calling it from outside, and its return type will be obviously boolean. Let me name it as find words. Okay. And in this we need to pass one index, right? So we need to keep tracking the length, right, to identify that we are done with all the character iteration, right? And after that we need to check the flag, right? So we need two things as input. One should be int index. Initially we will start from the 0 character and it will go till word dot length, right? And we need the word, so it should be string word. Then again what I need my index, right? So it should be a try node, sorry, my actual root node, right, from where I need to begin. So it should be, let me name it as node only. Okay, so now move forward. So what I need to do, so at first there should be one scenario, right? So suppose I found all the character, then I need to check that my length is equal or not. So let's check that. So if index equals to word dot length, then that means we found all the 5 character. Now we need to check, is that a really end, right? So we can just directly return it should be node dot isLeap, right? So whatever is the value is, if it's true then true, if it's false then false, right? So this is for the last condition when we will find all the characters. So let's now let's forget this part. Now let's consider from here, right? We are searching for apple, we are here now. So I need to check that this node is exit or not. If it is exit, that means A is present. If it is not, then A is not present, right? So let's do that. So let's check that. So how we can check that? So basically what I need to do, I need to calculate index once again, right, to get the index. So it should be int j equals to, and it should be word dot char at, and since we are starting, we are keep tracking everything using this index variable. So it should be char at index, again minus a to get the actual index, and I am going to return what I am going to return. I am going to check two conditions that. Okay, so before that I need to find that temp node, right, also. So let me take one node called Trie equal to temp node, something like this, and it should be node dot child, and it should be index should be j, right? So if it exists, that means that character is found. If it is not found, then we are going to return false. So what I will need to check, so in this condition I will going to check return temp node equals not equals to null. If it is equals to null, then we are going to return false, right? So not equals to run, and if it is not equals to run, then we need to check further, right? So similarly we need to call this function as recursion. So find words, again in this case my index will be found, since we found our first word, so we are going to increase my index, so index by 1. Again after that we need to pass my word obviously, and I need to pass my temporary node, right, as my I need to move further, right? Okay, I think that's pretty much for the search itself. Okay, and whatever it is, it will return, we are going to return that. Okay, so now let us call it from here only, right? So let's call it, so return what we will call here, again we will call this find words method, and we need to pass index in, since we are starting from 0, we need to pass the 0, then word, then this temp, right, root or temp, something like that. Okay, I think that's pretty much for search. Now let's do it for starts with. And so similarly, basically for start twist also we are going to use the same logic as search, but we don't need to check this condition, right? We don't need to keep tracking the index, right? Because suppose we are in checking for app, right? So app length is 3, so there is no point to track the app, right? Track the index or length, right? Since apple is length 5, app is 3, so we need to just check a is exist. If a is exist, then I will check for the next one. P is exist. Okay, it's exist. Then I will move forward and I will check if next P is exist. If it exists, then I'm going to return true. Else I'm going to return false. Right? We will not bother about the rest of the portion. Right? So let's write logic for the same also. So how we can do that? So we can again take one temporary node, and it should be temp node, something like this. And again I'm going to initialize root here. Now what I need to check? I need to probably run one for loop, so it should be unchar. So I am going to use enhance for loop. I am going to similarly I am just going through each and every character and I am going to pick the index. So it should be prefix to char array. So I am just converting it to char array, and once we are done with that, now what I need to do inside this for loop, I need to pick the index, right? So I will check that if my temp node dot child and index will be c minus a. Basically this is the same thing we are doing. It's a shortcut kind of thing. Equals to null, then that means it's not exist, then we can return false from there. Else if it is not returning false, then we need to move forward, right? We need to move further. So I found so suppose I am searching for app, right? And I found a. Now I will come here, right? So now I found a. Now I need to check here, right? So let's do that. So how we can do that? So again I need to increase my counter, right? So my temp node will be temp node equals to temp node dot child. It should be child, and it should be okay. So it should be temp node child, and what will be the index? So it should be c minus a. Okay, something like this. And if it is not returning false inside this for loop, then that means we found all the required character, and we need to return true from there only, right? It should be returned true. Okay, now I think we are pretty much done. Let's run our code and check whether it's compiling or not. I think it's throwing some error. Let me fix that quickly. Okay, it's double equals. Okay, it should be single equals, and anything else. Let's run it once again and check. Okay, I think there is another one in line number 51. Let's fix that also quickly. Basically it should be, since it's a Java, it should be 1 equals. Okay, so I have done some typo here. Everything will be try node instead of tree node. Let's check that quickly. Is there anything still there for tree node? Yeah, I think we have tree node. So let me rename it to try node one by one. Okay, I think that's enough. Yeah, I think the solution is running now, and its runtime is 5 seconds. So basically I fixed all the errors. So there was some typo for tree node and all. Now let's submit our answer and check, right, whether it's accepted or not. Yeah, I think it's accepted. Our solution is accepted, you can see. So now let's go through our code. Let us give the so let us go through our code and try to understand what we are doing here, right? So for the insertion, right, so what we have done at first, we created this pojo, right? So this is our pojo. We are taking sleep to track the end of a word, and we are taking child array. So it should be size will be 26 always, since we are considering A to Z. So while inserting, what we are doing here, so we are going through each of the character of the particular word, whatever we want to insert, and checking that is there any node existent node. So since we are doing checking, we are taking integer array. So we are need to convert this using this minus a. So since using the ASCII value, we are just taking the integer index of that particular character, and we are checking that So since we will start with root, right? So I will check that A is exit for so index of A is exit in our existing try or not. So if it is null, that means it's not exit. We are going to initialize one new node for the same, and we are going to insert A there, right? Then I will move further, right? And what I will go till end, and whenever at the end we are going to set it true, right? So that means that's the end of word, right? So basically for searching, what I'm doing here, we are using the recursion. So this is our searching logic. We are doing similar thing. So we are taking index. So that's the index. So suppose I am searching for apple, right? So my index will be initially 0. And I will find, okay, A is already there. Then I will move further. My index will be 2, 1, right? Again, it's there, right? And for each and every, before calling a recursion, we are checking the index, right? So whenever I will see that my index is reached to 5, since the apple length is 5, I am going to stop my execution. I am going to check that it's end or not, right? So similarly, like this, we will come here and here. My index will be 5. And I will see that, okay, and I will find, and I will also see that my flag is also true, right? Isleaf flag is true. Then I am going to return true, and I will say that this word is exist, right? So that's what I have written here for search. And similarly for start switch, we don't need to keep track this flag thing, but rest of the portion is like search only, right? So I will check this: is this exist? Is this exist? Is this exist? If all the 3 characters exist, so suppose I am doing this, right? Starts with app, then we are going to return true. I think that's pretty much for this video. I hope you understand this video. Let's do some time complexity analysis also before we close this video. So for the insertion, right? So suppose I am going to insert apple. So how, at worst case scenario, how much time it can take? So basically, in the worst case scenario, what can happen? That no node is exist, right? So in that case, we need to initialize 5 new node, right? So it should be order of n. N is the word size, right? So for searching also, we need to check for each and every character. Again, the searching is also order of n. So basically, insertion and searching is both is order of n. N is the word length. I think that's pretty much for this video. I am going to add the code link in the video description. Thanks for watching. Bye bye.